All right, the last section of chapter 2, solving. There's the key here. We're going to be solving radical and rational exponent equations. All right, so the first step is to get the radical alone, whatever the index number is. Okay, it could be a square root, it could be a cube root, whatever. Take both sides of the equation to the power that matches the index number. That's that little number outside. Solve and then check. So example 1. Here is my radical. I need to get it by itself. What's attached? The 2 by addition. So I subtract. This is a square root that equals 7. So now what I'm going to do is I'm going to square this because that will undo the square root. And I do that to both sides. So that gives me x minus 4 equals 49. And then I'm going to add both sides, 4, and that's 53. And then what I want to do is I'm going to take this and plug it back in and check it. 53 minus 4 is 49. Square root of 49 is 7, plus 2 is 9. Check. Now, when solving radical equations, it's very important, extremely important, to check for extraneous solutions. These are numbers that look like solutions, but do not work when you check them back in. Okay? So, again, here's my radical. I need to get rid of this and this. Always undo the plus or minus first. Okay? So I'm going to leave this, and I'm going to subtract 7 from both sides. And then I'm going to divide by 2 and get square root of x equals negative 3. And since this is a square root, I'm going to square both sides. And that gives me x equals positive 9. I'm going to check that back here. Square root of 9 is 3. 3 times 2 is 6. 6 plus 7 is not 1. So that is extraneous. All right, here is my radical. I like to put a box around it just to remind myself what needs to be alone. I'm going to add 2 to both sides. So that's going to leave me this cube root. We're finally doing a cube of 4y minus 1 equaling 7. When I add 2 to both sides, I get 7. Now, since it's a cube root, I'm going to cube both sides. That again undoes the radical, leaving me just the 4y minus 1. On this side, I get 7 cubed. So 7 cubed is 343. I'm going to add 1 to both sides. And then I need to divide by 4. So 344 divided by 4 is 86. I need to plug this back in here and check my work. So I'm going to do 4 times 86, which is 344, minus 1, which is 343. And then I'm going to take the cube root of that, which is 7, minus 2 is 5. It checks out. Okay, now in this one, notice this is a square root. But I have a variable over here. It's going to be a little bit different. When I do this, this goes away, but I have 4x plus 12 equals x squared. Well, we need to get everything on the same side, so these are both going to come over. I want to keep my x squareds positive. That's why I'm moving 2 things. Instead of just moving the x squared, we want to keep it positive. So that's going to be x squared minus 4x minus 12 equals 0. And now this goes back to factoring. We've got to be able to factor. So we need 2 numbers that multiply to give us 12 that differ by 4. So 1 times 12, 2 times 6, and 3 times 4 all give us 12. These 2 differ by 4. Okay? Now, I want more negatives than positives. But now I got to set these both equal to 0 and solve. So my answer is not negative 6 and 2. Actually, my answer is positive 6 and negative 2. And now I'm going to plug them both in and check my work. So 6 times 4 is 24. Okay. Plus 12 is 36. The square root of 36 is 6. And if I plug in 6 right here, I get the statement 6 equals 6. That's good. So that checks out. Negative 2 times 4 is negative 8. 12 minus 8 is 4. Square root of 4 is 2. But if I plug it in here, I'm going to get the statement 2 equals negative 2, and that's a false statement. So this is a no. This one is extraneous. All right. Over here, a lot going on. I need to get this by itself. First, I'm going to minus 2. Now I got to divide by 3. Both sides. That's going to give me negative 5 equals the cube root of 5y minus 1. Since this is a 3, I need to cube both sides. That gets rid of this. A negative times a negative is positive, times another negative is negative. 5 times 5 times 5 is 125. Giving me 5y minus 1 left over here after the radical goes away. I'm going to add 1. Be careful here. When you add 1, you end up with negative 124, not negative 126. Common mistake. Having a lot of trouble today. And we're going to divide by 5. And 124 divided by 5 is, y is negative 24.8 exactly. Okay, so let's test our answer. We're going to plug it back in. We're going to do negative 24.8 times 5, which gives us negative 124. Minus 1 is negative 125. The cube root of that is negative 5. Times 3 is negative 15. Plus 2 is negative 13. And that answer checks out, even though it's a decimal and even though it's negative. All right. Now, this is actually the easy one. If both sides are the same radical index number, okay, and that's the only way we'll do it to you, it's very easy. You literally square both sides in this case, and you're left with a very simple algebraic equation. 2x plus 5 equals x minus 12. I'm going to keep my x's positive. I'm going to move the 5 to the right. So that's going to give me x equals negative 17. Now I'm going to check my answers real quick. 2 times negative 17, okay, is negative 34. Plus 5 is negative 29. And then negative 17 minus 12 is negative 29. Now you may say, wait a minute, we can't have a square root of negative. That's true, but that is a true statement. The square root of negative 29 is equal to the square root of negative 29, so that answer checks out. And remember, just because we can't do square roots of negatives now doesn't mean we won't be able to do them later. So that is a true statement. Negative 17 is the correct answer. Over here, since it's a 3, we're just going to cube both sides. And that leaves us 5x minus 2 equals 2x plus 13. Again, I like to keep my x's positive. So I'm going to move my numbers to the right. Gone, gone. 3x equals 15. Divide by 3, x is 5. I'm going to plug it back in. 5 times 5 is 25, minus 2 is 23. 5 times 2 is 10, plus 13 is 23 underneath the radicals. That checks out. All right. Steps for solving a rational exponent equation. Change it to radical form first, and then it's going to be just like what we just did. This is the cube root. So all you do is change this to a cube root like so. and then do the rest like you had it. And now we're going to do exactly what we just did. We're going to get this by itself by subtracting 5. Seven minus 5 is 2. Now, to get rid of the 3, we're going to cube both sides. That's 2x minus 3 equals 8. 2 times 2 times 2. Going to add 3. Divide by 2. X is 5.5. Now, we plug it back in right here. 2 times 5.5 is 11. Minus 3 is 8. The cube root, or 8 to the 1/3, is 2. Plus 5 is 7. Check. Answer works. Okay? Again, we're going to do the same thing. In fact, you could even just do this right there if you wanted to. It's a square root. It's the same thing. It means square root. So I need to get rid of the 4 first by adding 4, which will give me 32. Then I'm going to divide by 2. And now, since this is a square root, I just square this. Okay? So that leaves me just the x plus 8 over here. And then 16 squared is 256. I'm going to minus 8, and x equals 248. Which again, I just can plug in real quickly. 248 plus 8 gets me right back to that 256. Okay? And then the square root of 256 is 16. 2 times 16 is 32, minus 4 is 28, and we have a good answer. And last but not least, again, if you want to write this right here, just like that, that's all it is. It's the cube root of x plus 3. I'm going to get rid of this 8 first by subtraction, which will give me negative 4. 4 minus 8 is negative 4. Equals the cube root of x plus 3. Which now I simply just cube to get rid of it. I have to do that over here. So think about it. 4 times 4 is 16 times 4 is 64. And negative times a negative times a negative is negative. And what's left over here? Just x plus 3. Now when I remember, when I subtract 3, I'm getting more negatives. So that's negative 67. Which I'm going to plug in here. Negative 67 plus 3 is negative 64. You borrow $67, but pay 3 back, you still owe 64. The cube root of that, or negative 64 to the 1/3 power, is negative 4. And negative 4 plus 8 is 4. Check. And that's it. Okay, numbering here is wrong, but same thing. So on this one, remember, this is the same as the square root. So we're just going to square both sides. That's going to give me 6x plus 27 equals x squared. I need to move these over here. So that's x squared minus 6x minus 27 equals 0. Now, I need two numbers that multiply give me 27 that differ by 6. That's pretty easy. It's just 9 and 3. Really my only choices. So x, 9, 3. I want more negatives than positives. And when you set them equal to 0, we get 9 and negative 3. Again, we need to check our work. So 9 times 6 is 54. Plus 27 is 81. Okay? Square root of that is 9. Well, 9 equals 9. Check. When I plug in negative 3, I get 6 times negative 3 is negative 18. Plus 27 is 9. Square root of that is 3. But then I get the statement 3 equals negative 3, which is false. So that is an extraneous answer. Example 5. Sorry, well, it's numbered 5. I need to get this by itself. Now remember, that's the same thing as square root of x. So I'm just going to subtract the 5. 22 equals 2, square root of x. Divide by 2, square root of x. And then to undo this, I just square it on both sides. That gets rid of that. I get 121. Plug it back in. 121 to the 1/2, which is the square root, is 11. Times 2 is 22. Plus 5, 27. Check. Now this one, remember, these are both basically square root of 2x minus 7 equals square root of 4x minus 31. So when I square both sides, just like right here, if I took a power to a power, I multiply 1/2 times 2, it cancels. So this leaves me with just simply 2x minus 7 equals 4x minus 31. Again, I like to keep my x's positive, so I'm going to move them right this time, which means my numbers go left this time. Cancel, cancel. So 31 minus 7, okay, is 24, equals 4 minus 2 is 2x, x equals 12. Plug it back in real quick. 2 times 12 is 24. 24 minus 7 is 17. 4 times 12 is 48. 48 minus 31 is 17. That's a true statement, so 12 works. And here we go. Sometimes rewriting the rational exponent into radical form won't help us solve the problem. Okay, like x to the 2/3 minus 5. When this happens, we isolate the part with the exponent and then use the reciprocal. So I just kind of hinted that. 1/2 to the second power, 2 undoes the 1/2. Same thing here. So we're going to get it by itself, again, like we've been doing, adding 6. But now, we're going to take this power to a power of the reciprocal. Those cancel, leaving me just this. Now, we can just type this in our calculator, but it's also really easy to do in our head or with the sheet of paper on our desk. So we're going to take 16 to the power, that little caret there, of 3 divided by 2, or 1.5. Okay? And basically what we're doing is, I like to do this first, keep it small. The square root, because that's really 3 times 1/2, right? So I'm going to do the square root, 1/2 is 4, and then 4 cubed is 64. But we also have the calculator, whatever works for you. So here, again, need to get this by itself, add 7. $54. Divide by 2, 27. If it's 3/2, the reciprocal is 2/3. 2/3. That all cancels, leaving me x plus 5, going to be an extra step here, equals, now again, you can put this in the calculator, but it's really easy. The cube root of 27 is 3, and then 3 squared is 9. And now we subtract 5 and get x equals 4. And I forgot to do this up here. Whoops. Real quickly, check. Okay. The cube root of 64 is 4. 4 squared is 16. Minus 6 is 10. Up here, we said the answer was 4. Plus 5 is 9. Okay. Square root of 9 is 3. Cubed is 27. Times 2 is 54. Minus 7 is 47. And our answers check out. And that is the end of the lesson.